Hey there, Algebra 2 students. I'm taking a look at your linear programming problem number 3. There's two other videos that kind of walk through this idea of guess, check, generalize, how to set up a system of equations and inequalities. And so why don't you pause your video for just a moment, read through this, take a couple of notes. How would you approach this question? Are you ready to try the guessing, checking, and generalizing strategy? So go ahead and pause, and when you think you have a little bit of an idea, come back and we'll try to walk through this in one way. So you read through this. You can take a look at how I kind of walk through it, and I see there's all these different things we have to understand. Student tickets sell for $4, adult tickets for $8. There's a maximum of 110 people. They have to make at least $570. And there has to be at least 20 student tickets, and there can be no more than 70 adult tickets, right? The maximum, minimums, all these things from inequalities. And it says, let X represent the number of student tickets, so here's X, and let Y represent the number of adult tickets. So we're going to write and solve a system of inequalities graphically and determine one possible solution. So we need to know a number of student tickets, a number of adult tickets. And so this is where I say, make that first guess, all right? And if you see, it says we can only have 110 people, all right? Only 110 people, 20 students minimum, 70 adult tickets maximum. So whatever your guess is, I'm going to just guess 50 students. Why? Because it seems like a good, easy guess to me. So if I have 50 students, how many adult tickets would I need to sell? Well, it says I can only have a maximum of 110 people. So let's get the max. Let's say if I have 50 students, I would have 60 adults, because together they have to be less than or equal to 50, or sorry, 110. All right. So think about that, right? 50 and 60, that gives me 110. That's the most I can have when I add these two together. All right? And so this is where that math comes in the guessing part of this. So you have to make a good guess. All right. So now that we know our first guess says 50 students and 60 adults, did we make at least $570? So how would we figure that out? Well, the money side of this, right, and I'm going to do the money over here, says that for the 50 students, I'm going to multiply it times $4. All right, 4 times $50. And then the adult tickets each are $8, so I'm going to add $8, that's a dollar sign if you can't tell, times 60. So 4 times 50 is $200. 8 times 60, well, I do 8 times 6. I never get that one right? I know 7 times 6 and 7 times 7, but 8 times 6 always confuses me. So maybe sometimes I do something like, well, 6 times 10 is 60, so it'd be 8 less than 60 would be 7. Yep, that's how I do it. So 60 minus 16. Are you following me? Maybe not. 6 times 6 is 36. 6 times 7 is 6 more, so that's 42. Then 6 more is 48. Okay, so that's 480. Again, you could have used a calculator, but my brain's getting old, so I have to make sure I do that. So that's 200 and 480. That's $680 total, which says we have to make at least $570. So is this at least $570? So I want this to be more than that or less than that? Oh, at least. That means this is more than that or equal to. And I'm just going to keep writing that down because it's going to help me think through this. So is $680 more than 570 or equal to? Yes. Okay. So what's pretty cool is I already found one solution that does work, but I haven't done it graphically yet. So we want to be able to graph these solutions and see what that means. So let's take one more guess. take a moment, write all this down as guess one, okay? So how you did it, what you have for guess one, the money for guess one, and then we're going to come back and we're going to guess again. So our first guess worked, but if you can't quite see how to write these equations, let's take another guess. So guess two, let's guess we only had, 20 adults. So if we had 20 adults, how many students could we have? Well, it says we have to have at least 20 students. So let's just say 20 students, 20 adults. All right. Is that less than or equal to 110? Yeah. So small crowd, maybe it was cold that day, right? So 20 plus 20 is less than 110. Now, do you see in this first guess where the 50 and the 60 went? Okay. It was 4 times 50 and 8 times 60. Those are our guesses. I'm going to erase these two numbers just so you can see where we're going to put these guesses. So hopefully you took good notes on that first guess. 20 students, 20 adults. Let's see, is that greater than or equal to 570? So 4 times 20 is $80. 8 times 20 is $120. Is that greater than or equal to $570? 80 plus 20 is 200. Oh, no, that guess did not work. No, that doesn't work. All right, but that was a good guess. All right, so go ahead and guess another set. All right, 1 second here. I got a call from a student, so just wait 1 second. All right, so we saw our second guess didn't work, but are you kind of seeing how we have to program this, right? How we need to make these questions work, and we're really asking ourselves, does it work for each of these situations? So why don't you take another guess, make sure it fits all the criteria here that we have, and then we're going to try to graph these together. So pause this, try it out. I'm going to do another guess. We'll come back and walk through that guess. Where do we plug it in? What's the equation start to look like, okay? All right, so hopefully you were able to do another guess on your own, and you start to see where you plug those in. I said equations, but these are actually inequalities, right? So again, 50 and 60 adults, we said that one did work. 20 students, 20 adults, that one did not work. So let's do one more. Let's just say we have the maximum number of adults was 70. We need to stay under 110. So let's say each of those 70 adults brought, well, let's say just a total of 20 kids again. All right. It was a late one, so we didn't have as many kids. So that 20 students, right, plugs into this equation, 20. The 8 adults plugs in for $8 times the adults. And we want to see, does that equal $570 or more? Because this idea of they have to make at least that much money. All right. And so 4 times 20 is 80. 8 times 70 is 56. So 560. So 560 plus 80. Well, yeah, I can see that's going to be enough. So 560 and 80 is $640. And that is definitely greater than 570. So yes, this one would work too. So we have solutions. Guess checking isn't about finding the right answer all the time, although if you guess and check, you can find the right answer. Your goal in this situation is to find all the right answers or find where they could end up. So let's talk through these equations. If I said students are X and adults are Y, do you see how the number of students X, the number of adults Y have to be less than or equal 110 tickets? So here's our first equation, right? X plus Y is less than or equal to 110. And that's kind of our quantity equation. How many tickets? Well, then our money equation over here is 4 times the number of students X plus 8 times the number of adults Y has to give us enough money so that we have more than $570. So these are the two equations that we found kind of using this guess check and then generalizing idea. But with this system of equations, remember, we had some other things we had to make sure that we watched out for. So we said there has to be a maximum of 110 people. That's this one right here. We said they have to make at least $570. That one's there. But look at these next two. They must sell at least 20 student tickets. right? So how do we show at least 20 student tickets? Well, our number of students, which we said was X, has to be greater than or equal to 20. At least 20. All right, and a maximum of 70 adult tickets. Can you think of what that might look like? So we want the adults and 70 to be together, but do we want to be more than 70 or less than 70? Right. This needs to be less than 70. It says a maximum means we could have 70, so we could also put that equal sign there. So if we look at this, we have these four equations. Awesome. And by equations, I mean inequalities, right? Equations have an equal sign, inequalities have this greater than or less than sign. So write down these four inequalities. We're going to throw those on the graph. All right, so click on a Desmos graphing calculator and join me. All right, so here we are at desmos.com. I'm going to grab this graphing calculator, open it up, and the first equation that we came up with, I'm running out of space here. All right, so there's some more space. So let's use our two equations we came up with last, right? X is greater than or equal to, so you hit that sign that looks like this, then the equal sign, and it changes right to here, is 20. Okay, oh, I can't see that, so what do? I go over here and I zoom out. Look at this. So X is students, so it shaded everything to the right of 20, which means we could have 20 tickets, 30 tickets, 40 tickets, 50 tickets, all the way up to, as many student tickets as we want. That's that bound. Go ahead and click here. Y has to be less than, see the little less than symbol, and then equals to, and it puts it underneath 70. So that's the adult tickets, but I can't see up that high, so I'm going to zoom out a little bit more. And you can see this is 70 right here. And so everything less than 70 is highlighted for that Y. And you can already see where our overlap is, right? We have this point, it could be 20 student and 70 adult. They overlap. And then we have this whole section here that's still overlapping. But together we can only have 110 tickets. So we're going to do that. X plus Y has to be less than or equal to 110 tickets. And see how that is a diagonal inequality. And you can see where it starts to intersect here. So right here I have 110, 0. So that's 110 student tickets, 0 adult, right? And you can do that math in your head. 4 times 110 is $440. So that's not actually a solution, but it's a possibility. Here 4070 is on there. We can still see this point 2070. And we start to see where all this overlap's happening. So let's put in our money equation, right? It says $4 times each student plus $8 times each adult has to be over, right? We have to make at least this much money, so it's greater than or equal to $570. And so now we have this major overlap, and you can see where each of these graphs go. So I can eliminate that, and you can start to play around with this and see how each of those affect this situation. So everybody see this weird looking, what would that be? 1, 2, 3, 4-sided figure here that has a point right here, 2070, a point right here, 2061.25. There's another bound right down here, 77.5, 32.5, and then this bound right here, 40 and 70. Now, each of those are the bounds that could make this true. But what else could make this true? Any point in that overlap. So pause and think about some of those solutions that could work. So if you remember 1560 and 2070, those are two things that worked for us using those bounds. Let's grab this image one more time here. And let's look at what this graph means. And if you're trying to make that $570 at least, right, anything that falls within these boundaries right down here, I can't get too precise, but you can see this. Anything that falls inside of these bounds right here could be a solution. So go ahead and pick a few of those points, test it just to make sure, because you never need to get one of these problems right, because you could test a point here just to make sure that doesn't work,